Okay. These notes are these questions that are on the notes are very common FRQ questions. Okay. So we already learned how to find the area under the curve of a function. And that's where we would, in the very beginning, highlight the area between the function and the x-axis and use Riemann sum. Okay. And then we later learned that that's the same as integration. So we would just integrate using a certain bounds of the area under a curve. But now let's say we have more than one function. Okay, so let's start with, let's say this one right here is function f. And this one right here is function g. So now instead of asking you the area underneath one of these functions, they're going to say, what is the area between these two curves? So really what it's asking for is this here. Okay. The area between the two curves. In order to find this area, you're going to have to also find where these two things intersect, the two functions intersect. So you'll need the intersection here, and you'll need the intersection here, and those are going to become your bounds for your integral. Okay, your bounds for your integral. Okay. So putting this into a formula, this is the integral from a to b, so your bounds where they intersect, of f of x minus g of x dx, where f of x is greater than or equal to g of x for all x in the interval a to b. So what this means is when we are putting the function inside of this formula, whatever function that is on top of the area is going to be our larger function. So in this case, the function on top of that shaded area is which one? F of x. So that is our larger function, so that is going to come first. And then the function that is on the bottom of our area is going to be our smaller function, and that's the function that we're always going to subtract. So in our case here, we have f of x minus g of x based on the position of the functions around that shaded area. Okay. So for number 1, it says find the area bounded by the curves y is equal to x squared plus 2 and y is equal to negative x. And then it even gives you the bounds here of x equals 0 and x equals 1. So at those bounds, so x equals 0, I'm just going to draw some lines. So from 0 to 1, and it wants the area between those two curves. So it's going to be this shaded area here between the quadratic and the linear function. Okay. So if I was to use that formula, this would be the integral from 0 to 1, and which function is going to be on top, the quadratic or the line? Quadratic. So we're going to do that first. So that is x squared plus 2 minus the bottom function, which is the line. So that's negative x dx. Okay, well, we can simplify that, and what we'll notice is we end up getting a quadratic here. So this is the same as saying x squared plus x plus 2 dx. And if it's something easy like this to integrate, since this is just a bunch of the power rules, okay, we're going to go ahead and show the integration step before we plug it into Desmos to get our answer. Okay, so for example, this would... Can someone get the phone for me? This would be 1/3 x cubed plus 1/2 x squared plus 2x. No, like pick it up and just say Miss Marcos' room.
Derek is going home.
Okay.
Really?
Yep.
Cool.
Okay. Thank you.
That's awesome.
Okay, these notes will be recorded and uploaded next period.
Absolutely.
Okay, bye. Have a great day. Okay, where were we? Okay, so we're here. We're at this point. We integrated this. We said solved at 0 to 1. And then if you want to solve this, which means you would plug in 1 and then you would subtract and then plug in 0, you would get an answer. Or just take this part right here and plug it into Desmos. Okay, you have access to it. Might as well use it, right? Okay, plug that into Desmos. Just remember when you plug it into Desmos, you need to have parentheses around your function before you put dx. So go ahead and take a minute, go ahead and type that into Desmos. And then as soon as you get an answer, let me know what you get. Good, 2.83 repeating. Right, it would be 3, 3, 3, 3, etc. Okay, which means this is the area between those two functions with the bounds 0 to 1. Any questions on 1? Bless you. Okay, number 2 says find the area bounded by y is equal to 2 minus x squared and y is equal to x. Okay, this would be a more common problem to show you because for one, they didn't give you the graph. Okay, so you're going to have to know how to graph this just to get a general idea of which function is on top and which one's on bottom. And then it also doesn't give you the bounds, which means you're going to have to find where those two functions intersect. So the first thing I'm going to do is I'm going to draw a graph. Okay, I know that y equal to x is my parent function for the linear equation, so it's going to go through the origin. And then y is equal to 2 minus x squared is a quadratic that is negative, and it's going to go through the y-axis at 2. So it's going to look something like this. And it wants the area bounded between these two functions, so it's going to be this area here. Okay. The only thing with that is that we are not given the bounds. So these two intersections here. And so in order to find that, we can either graph this on Desmos, right? And it will give you the intersections. Or we can take these two equations and set them equal to each other since they are both set equal to y. So this is 2 minus x squared is equal to x. Okay, get everything on the same side because it's quadratic. And you get x squared plus x minus 2 equals 0. Which from here, we factor, and everyone knows how to factor, right? Hopefully this point of the year. Okay, and so you would factor this. Anyone want to give me the factors?
Positive 2 minus 1.
Okay, so x plus 2, x minus 1 equals 0, which means I have the bounds x equals negative 2 and x equals 1. These are my bounds. Okay, so then I'm going to do the integral from negative 2 to 1, and which function is on the top? The quadratic. So I'm going to do 2 minus x squared minus the function on the bottom, which is x, dx. Okay, this is very easy to integrate, so I'm going to show that step. And so I have 2x minus 1/3 x cubed minus 1/2 x squared, solved at negative 2 to 1. But you can go ahead and take this equation here, put it into Desmos, and tell me what you get. Anyone get an answer?
4.5.
4.5. Perfect. 4.5. Okay, any questions on 2? Yes.
In the parentheses, why did we make the other x negative? Like 2 minus x in second and minus x, and not plus x
Minus x for...
for the integral? Why did we do like minus x and not plus x?
Oh, because we're always subtracting the two functions. And so when we subtract the linear function, It's minus x because that linear function is positive, so it's minus x.
Okay. Oh, right. Musical equation.
Yes, if we look at number 1, we did minus and negative x, so that's why it turned to plus.
Okay, got it.
Mm-hmm.
How do we know it was greater?
Say that again?
How do we know it was greater again?
Because it's the function that's on top of the area.
Okay.
So that is the quadratic, and so that's why we did the quadratic minus the line. Okay, number 3 says set up the integral that allows you to find the area in the first quadrant that is bounded above by y is equal to square root of x and below by y is equal to x minus 6. Okay, so notice in this function here, they give us the graph. It wants us to find the bounded area, but notice that the line and the square root function is not encompassing the area entirely on the x-axis, which means that area is only between the two functions starting at x equals 6, right here. Okay, that's all this where it's between. Okay. Everything up to 6, we only care about the area under which function?
Square root of x.
Good, the square root of x. Okay, which means we're going to have to do the integral from 0 to 6 of just the square root of x. And then we're going to add it to the integral of 6 to what? 9, where we subtract the two functions to find the area between. Okay, again, it would be different if they also shaded this region down here. Then it would be between the two functions the entire time. But since they only want that positive area above the x-axis, that means we're really only looking at the area between the two functions after x equals 6. Okay, so where I highlighted in red. Okay, which means we would, again, do the integral from 0 to 6 of the square root of x dx plus the integral from 6 to 9. And then the function on the top, if we're looking at the part I shaded in red, is going to be the square root function or the line? Square root function. So this is the square root of x minus, minus the line. So instead of saying minus x minus 6, I'm going to make sure I put x minus 6 in parentheses because that entire function is being subtracted, and then dx. Okay. And again, for this question, it just wanted us to set up the problem. It did not want us to solve. Okay, but we could easily solve this by plugging it into Desmos and getting an answer. Any questions on 3? Okay, number 4 says find the area bounded by the curves y is equal to natural log of x and y is equal to 1/2 x minus 1. So in this case, we also are not given a graph and we're not given the bounds. So remember, I said the other way we could do this is we could graph both those functions and see where they intersect. So let's go ahead and do that method this time. Okay, so I have y is equal to natural log of x. Okay, and then on the next line, I have y is equal to 1/2 x minus 2. Oops. Okay, I can reposition this. Let me bring that down so I can reposition this here. Okay, I can go ahead and draw that rough sketch on my notes. Okay, so I'm looking at the area between the two functions here. Okay, so in order to find those bounds, then I can either set these functions equal to each other and solve for x like I did before, or I can click on Desmos and it should pop open those points here. So that's where it intersects. Okay, and of course we're looking at the x values, not the y values. But notice, since this problem said be careful with a rounding error, both of our bounds are numbers with lots of decimals. So we need to make sure we include all those decimals so we don't get a rounding error later. So I'm going to state that my bounds is at x equals 0.14555 and x is equal to 8.21093. Which means I have the integral from 0.14555 to 8.21093 of which function first? Natural log of x minus my line, so 1/2 x minus 2 dx. Okay, once I have that set up, then I'm going to go back to Desmos, I'm going to type in that integral, and I'm going to get an answer. Okay, and when I do that, I get 8.784. So once I get down to that final answer, it's okay to round to 3 decimal places. But if you want to try on your own later on Desmos, let's say you rounded this too soon, which means you rounded your bounds. And I guess I can just show it here. So let's say you rounded it to 2 decimal places. Okay, notice how, okay, this one wasn't as dramatic as I thought it would be. Okay, notice how the decimals at the end changed, right? So if you were, let's say, looking at a multiple choice problem and this multiple choice problem gave you all those decimals as your answers, you would want to make sure that you don't round too early in the problem because it can end up changing your final answer. Okay. Any questions on 4? We're doing so good on time, I could probably do another notes. But I won't. I won't. Okay, number 5 says, let R be the region bounded by the graphs y is equal to 2 square roots of x and y is equal to x squared over 4 as shown in the figure. If the line x is equal to k divides R into 2 regions of equal areas. That's important there. Go ahead and highlight that. What is the value of k? Okay, so we want to divide this into an equal area. Okay, we know that the bounds of this function starts at 0 and goes to what number? 4. Okay, so if we were going to write this of equal bounds, which means we need to take 2 integrals and set them equal to each other. Okay, so this would be us saying the integral from 0 to some value k, because we don't know what k is, we don't know where our half point is. Okay, then we would do the integral based on the function, so which one would be on top, so which one's first?
2 square roots of x.
Good, 2 square roots of x minus x squared over 4 dx is equal to, but when we write this integral, instead of doing 0 to k, we're going to do
0 to 4.
k to 4. Because so ultimately what we're doing is we're using the property that states if we were looking at the entire integral 0 to 4, okay, it would be the same as separating the integral into 2. And since we're saying that they're equal regions, we can set the integrals equal to each other. Okay, the same function is going to be there. So we're still subtracting all right, just move it down. I need more room. We're still subtracting the same functions here. So it's 2 square roots of x minus x squared over 4 dx. Okay. But notice, based on how many variables we have here, so k and x, are we able to just put this into Desmos? No, not yet. So what we're going to do is we are going to integrate this by hand at first. We're going to plug in 0k and then k4, and that way everything will be in terms of what variable? K. So once we have everything in terms of one variable, then we can use Desmos to help us solve that variable. Okay, so let's go ahead and start integrating this. So remember, the square root of x is the same as x to the 1/2 power. So this would be 2x to the 3/2 divided by 3/2 minus 1/4. I'm just taking out that divide by 4, putting it in the front. X cubed over 3, solved at 0 to k, is equal to the exact same thing, so it's exact same equations on both sides. So 2x to the 3/2 over 3/2 minus 1/4 x cubed over 3, solved at k to 4. And I need more space. You guys have lots of space because you're writing super small, right? Yeah. Okay. So then for each of these, to solve those certain ones, I would plug in k, and then I would plug in 0. But I really don't need to show when I plug in 0, because what's going to happen? It's going to end up being minus 0. So I'm just going to plug in k. So I have, and I'm going to take that 3/2 and do the reciprocal and multiply by the 2 in the front. So this is 4/3 k to the 3/2 minus k cubed over 12. 4 times 3, got that 12 on the bottom. K is equal to, but on this side I have to plug in 4 and I have to plug in k. So this side's going to be a little longer. So I have 4/3 times 4 to the 3/2 minus 1/4 times 4 cubes over 4 minus 4/3 k to the 3/2 minus k cubed over 12. Okay, so this is me plugging in the solved at values 0 to k and k to 4. So now that I have everything in terms of k, I need to figure out when these two are equal to each other. So what I'm going to do is I'm going to treat them like two separate equations, okay? And if I plot these two separate equations, they should intersect at two values, and I'll be able to find the intersections. Okay, so on Desmos, I am going to type in just the first part. And I think Desmos allows you to leave it as k. We're about to find out. Well, actually, I'm going to change it to x, because then I don't have to flip back and forth. Okay, so 3/2 minus... Okay, so there's my first one. Okay, on the left side of the equal sign. Then I'm going to do the next one. And the reason we're doing this way is that in first period, I did this by the InSolve feature on Desmos. The only bad thing about that is it only gave me one x value, so 1 point where it intersected, instead of giving me 2. And so we figured that it's better to show this way, just so you get both those numbers. Okay, so I should have both of my equation there now. I'm going to go ahead and drop this down. And then now that I have both those equations, I can clearly see where the intersections are going to be. This makes me feel like I typed something in wrong, though. Let me double check this. So 4/3 x 3/2 is 12. 3/3 minus 1/3. 4 cubed minus 3.
Why is it 4 to the 3 over 4?
From this part right here when I plugged in 4.
Will it be 4 to the 3 over 3?
Oh, okay, yes. There you go. There's my mistake. Thank you. Okay, yes, those numbers look better. Okay, so then what we end up with is K is equal to 1.764 and K is equal to 5.713. Okay, so looking at both those numbers, remember, we were only looking at the interval from 0 to 4. So what's the only K value it can be? Good, that first one. Okay, so it can't be this one here because this does not belong to the interval from 0 to 4.